Out in a deep, untouched rainforest, you can spend days without seeing another person. It's the kind of isolated environment where it's easy to believe an undiscovered animal might be hiding just out of sight. But if someone shows you a video of a creature deep in those woods today, the odds are it was simply typed into existence. AI tools like Veo 3 can generate photorealistic native 4K video of a Sasquatch brewing his morning coffee in a matter of seconds. For decades, researchers relied on a single blurry photograph as acceptable proof of an anomaly, like the infamous grainy silhouette of the Loch Ness Monster. In the age of generative AI, that standard of evidence is entirely obsolete. So how do serious investigators separate local folklore from an actual biological discovery? This diagram is the Cryptid categorization matrix, and it plots anomalous claims by weighing the level of physical evidence against the organism's biological plausibility. Down here in the bottom left quadrant, we have culturally embedded phenomena, like shapeshifters or little people. These possess zero physical evidence and defy ecological logic. But in the top right quadrant, we find putative biological phenomena. This is where physical trace evidence aligns directly with ecological plausibility. To successfully operate in that top right quadrant today, you have to completely abandon folklore-driven monster hunting and adopt the strict, verifiable protocols of integrative zoology. The methods you see on television, wandering around at night with flashlights, knocking on trees, or playing loud sounds to bait a creature, are derived from myth and reality TV production, not science. From a biological standpoint, active hunting guarantees failure. Blaring acoustics and sweeping lights immediately trigger a stress response in local wildlife, causing animals to bolt and altering their natural behavior long before you can get a visual. A human moving through a remote habitat acts as an environmental contaminant. If an unclassified species is naturally elusive, your active presence ensures it will stay far outside your detection range. If you look at the historical record, elusive local legends are rarely verified by people actively crashing through the woods trying to hunt them down. They are verified through patient, passive biological study. For years, the Sayola was nothing more than a local rumor in the Annamite range of Southeast Asia, until biologists patiently gathered the physical and genetic data required to formally classify it. And for centuries, medieval Europeans traded in magical unicorn horns, until naturalists finally traced the material back to its biological source, the spiraled ivory tusk of the narwhal. Banging sticks in the woods might provide a spooky experience for a late-night vlog, but it yields absolutely zero verifiable biological data. If you want to detect an unclassified animal, you have to remove the observer effect from the environment entirely. Field biologists achieve this using passive detection protocols. Standard optical night vision, or flashlights, require you to project light into the environment. Instead, investigators rely on high-end passive thermal imaging arrays. Thermal cameras don't emit a signal. They detect the natural heat contrast of an animal's body against its surroundings. This allows you to spot a target's heat signature glowing brightly from thousands of meters away, in complete darkness, cutting straight through fog, rain, and dense foliage, without spooking the wildlife. Cautionary: the trade-off is that thermal imaging rarely captures fine morphological details. You will see the heat signature of a bipedal or quadrupedal animal, but you won't get the specific hair color or facial structure required for a definitive taxonomic classification. To capture those ecological details without interfering, investigators pair thermal optics with robust acoustic drop rigs. These are professional, multi-channel digital audio field recorders left completely unattended in a habitat for 20 to 50 hours at a time, documenting uninfluenced natural acoustic behavior. But drop rigs are highly vulnerable. Leaving expensive, sensitive gear exposed means risking destruction from severe weather or tampering by curious animals. And reviewing 50 hours of ambient forest audio requires a massive investment of tedious manual labor. Despite logistical risks and high entry costs, passive monitoring remains the only scientifically valid method to observe a hyper-elusive species in its natural, undisturbed state. Capturing an anomaly on a camera or an audio rig is useless if you can't prove where, when, and how the media was collected. You have to establish an unassailable chain of provenance. In the digital realm, that means shooting in raw image formats that record unprocessed sensor data and using GPS-synced multi-camera triangulation to capture simultaneous angles of a single event, eliminating claims of AI manipulation. We can look at historical evidence to see why physical mechanics matter. Vintage 16mm cameras exposed actual physical film stock through a mechanical gate. Investigators can inspect the physical film for integrity, checking the frames for literal tape edges or glued splices to prove that a sequence hasn't been deceptively cut together. Today, physical evidence collection relies heavily on environmental DNA, or eDNA, and precise track casting. To collect this evidence, investigators use nitrile gloves, sterile sample bags, and rapid response deployment to ensure their own biological material doesn't cross-contaminate the site. Implementing these strict forensic protocols drastically slows down fieldwork. It requires specialized training, and if you fail to maintain sterility for even a second, the resulting sample is scientifically useless. Without a flawless forensic chain of custody, any piece of evidence you bring back from the field will be rightfully dismissed by the scientific community as a hoax, a cross-contamination error, or an AI fabrication. This flowchart maps out the investigator's decision tree, which helps you align your field approach with your actual intentions. It starts with one question: what is your actual goal? If you branch left, you enter the route of entertainment and content creation, which relies heavily on folklore methods like basic trail cams, vlogs, and active tracking. This path caters to amateur thrill seekers, social media influencers, and anyone who prioritizes personal myth-making and engaging stories over strict scientific validation. If you branch right, you enter the route of scientific proof. This demands biological methods, thermal arrays, acoustic drop rigs, eDNA sampling, and GPS triangulation. This demographic is built for serious researchers, integrative scientists, and field biologists who are willing to invest the grueling, tedious labor required for passive detection. The ultimate payoff of the scientific method is the ability to bring a legendary or unclassified species out of the shadows and onto the dissection table for verified taxonomy, like when deep-sea researchers finally documented the giant squid. Adhering to this rigorous standard is the only proven way to confirm the existence of an elusive, critically endangered, or supposedly extinct species. Serious investigation demands removing human ego and presence from the environment. You cannot hunt a biological mystery with a flashlight. You can only document it through rigorous passive zoological science.